Good morning to one and all present here. I am G. German from Sacred College, PG and Research Department of Mathematics. My topic is about reliability analysis of system using Markov models under the guidance of Dr. E. Mercelin Anita, Associate Professor, PG and Research Department of Mathematics, Sacred College, Tirupattur. Previous video we talked about two topics which is about introduction and basic concepts of Markov model. In this video, we thought another two topics, uh, final topics, system reliability analysis using Markov technique and applications of reliability technology in a agro-based industry with references. First, system reliability analysis using the Markov technique. This chapter about Markov model consists of 5 elements. The 4 elements have been derived in previous work. So in this chapter we derived 5 elements, and the 5 elements exist two states. One is good and failed. It is assumed to fail independently with the constant failure rate over a small time interval delta t, delta tau. The probability of transition good from there uh, from good state to failed state is approximately as lambda delta tau. The probability of more than one element failure in time t is considered as negligible. The Markov difference states are formulated by expressing the probability of each system states at time tau plus delta tau in terms of system states at time tau. The probability of system remains in state 1 at the time tau plus delta tau is equal to the probability in the state 1 and the time tau, and there is no transition out from the state during the interval delta tau. The equation of all good elements is P1 of tau plus P1 of tau plus delta tau, which is equal to P1 of tau of whole power 1 minus summation 1 equal to I equal to 1 to 5 lambda I delta tau. Here the diagram between state 1 to state 1s are good. From first row, one element is failed, so here element 1 is failed, here element 2 is failed, state 4 element 3 is failed, state 5 element 4 is failed, state 6 element 5 is failed, and the follow second row will become 2 row element, 2 element failed, third row 3 element failed, fourth row 4 element failed. Overall combined form a state 22, all the elements are failed. The equations of the one element failed is above the P2 of 1 delta plus delta tau equal to P1 of tau lambda 1 delta tau plus P2 of lambda 1 minus summation I equal to 1 summation I not equal to 1 because the one element is failed. Which element is 1? First element. So lambda summation equal to 5 lambda 1 to delta t. In state 3 second element is failed, state 4 third element is failed, state 5 fourth element is failed, state 6 is a fifth element failed. On the follow the equation of two element fails are here same the equation, but I equal to 1 comma 2, there are two element is failed, state 8 2 comma 3, state 9 3 comma 4, state 10 4 comma 5, state level 1 comma 5. These are the statement failed and equations are being derived. Here the three elements are failed, so first element, second element, third element are failed, remaining lambda 4 plus lambda 5 still here. Similarly, all those the equations are derived from state 2 to state 2 to state 21, because state 1 is all the elements are good. Here State 22 is all the elements are failed in the last stage. So we get the equation P22 of tau plus delta tau, which is equal to P17 of tau lambda 5 delta tau plus P18 of tau delta tau lambda 1 delta t plus P19 of tau lambda 2 delta t plus P20 of t lambda 3 delta t plus P21 of lambda 4 delta t plus 1 P22 of t. Initial conditions solving the problems. Initial P1 of 0 is equal to 1, P2 of 0 is equal to etc. equal to 0. To find the all the elements are good, so we take the first equation and derived P1 of t உள்ள எடுத்துட்டு போறோம். And actually just is a multiplication and இந்த பக்கம் எடுத்துட்டு வரும் k summation 1 equal to 5 lambda I வந்து நான் k1 எடுத்துக்கிறேன். So we substitute in this equation and derived by delta t, taking limit delta t is equal to 0. So we get the first order linear equation dp1 of t by dt plus k1 p1 of t equal to 0. We know that the first order linear equation dy by dx plus p of x y is equal to qx, if is equal to e tends to p dx, y e power, the solution is y e power interval p dx is equal to integral q e power p dx dx plus c. Combining the both equations, we get the p1 of t is equal to e power minus summation I equal to 1 to 5 lambda 1 of tau. Same finding the one element fail states as far as follow the equations above the steps. So we get the P2 one element failed, two elements failed, three element failed, and finally four element fails equation. Here the equations have been derived. All the elements are failed in P22 of tau is equal to 1 minus summation I equal to 1 to 22 P1 of tau. The system reliability is R of t is equal to summation I equal to 1 to 21 Pi of t. Failure rate on the f of tau is equal to 1 minus R of t. Here the example, ஒரு ப்ரொடக்ஷன் கம்பெனியில் 5 மிஷின் இருக்கு. அது வந்து இண்டிவிஜுவல் ஆப்ரேட்டர் டியூரிங் எ மிஷின் ஸ்டாப் ஒர்க்கிங் பிகாஸ் ஆஃப் டெக்னிக்கல் ஃபெயிலியர்ஸ் or mistakes in handling by an operator. From the maintenance data is provided lambda 1 equal to 0.09, lambda 2 is equal to 0.14, lambda 3 is equal to 0.19, lambda 4 is equal to 0.22, lambda 5 is equal to 0.30. Yes on the t is equal to 1, 2, 3. மேல இருக்க ஈக்குவேஷன்ஸ்ல சப்ஸ்டிட்யூட் பண்ணி கால்குலேட்டர் யூஸ் பண்ணோம். ஸோ வி கெட் த வேல்யூஸ். சேம் ஃபெயிலியர் ரேட் வந்து 1 மைனஸ் ஆர் ஆஃப் டி, இது 0.9174ல 1 மைனஸ் போட்டால் 0.0826. So that value we get. So let's finish the first chapter. Another last topic, applications of reliability technology in agro based industries. In the case study, butter or ghee manufacturing plant, agro based industries are essentially in economic development of country by converting agriculture raw materials into value traces path. Reliability failure technology contains failure prevention, predictive measures and preventive measures, reliability analysis tools, etc. Third one is third topic is manufacturing of ghee involves converting milk into cream, butter, final ghee we get. Here the process: raw milk, pumping unit, chilling unit, separation pasteurization unit, condensed butter making machine unit, melting wax unit, butter oil clarify packaging units. Here the first topic is analysis of system reliability system in system with the series and parallel condition. If the series is contains the one element, one unit fails, the total system is failed. This is a series. If the system of all system units contains across the same input and output points, if the one unit fails, another unit operates successfully. It's a parallel system. For series parallel system, in a system units are contained in a series and each unit subunits are contained in parallel. So So this is a equations of series parallel equations. These are so previous chapter we discussed the equations. These are so with the initial conditions p naught of 0 is equal to 1, p1 of 0 is equal to 0. We derived state 1 is a raw milk, state 2 is a pumping and reliability of stage 2 is a pumping and chilling unit. Here the diagram we constructed. So apply these equations, we get the r of 2. If then t is equal, t tends to infinity, we get the availability of it. Our reliability of state 3 is contains 6 units separation. Remaining 6 units are here the diagram. Here the series equations from r of s3 is equal to product of I equal to 1 to 6, product of j equal to 1 to 3, p of x 3 ij. We substitute the values, so we get this equation with availability t tends to 0. And finally, the conclusion in this project, the reliability system using the Markov model provides the effective methods for studying the behavior of system whose components are subject to failure and repair, and offered an organized probability framework of the system by representing systems as an transition between states. These models allow engineers to evaluate reliability and availability with a high level of accuracy because they can handle random failures and repairs. Markov models are widely used in engineering systems. These are my references. Thank you.